All right, let's get right into it. If you work with AI, you know the drill. We're all constantly trying to get better, more accurate results. We build these complex prompt chains, we do fine-tuning, all this really advanced engineering. But what if the biggest breakthrough wasn't complex at all? What if it was kind of embarrassingly simple?
No, really, think about it for a second. What if you could get a huge performance boost without changing a single piece of your infrastructure, without switching models, and, get this, without adding any real latency? It totally sounds too good to be true, right? Well, some incredible new research from Google suggests the answer is hiding in plain sight.
And here it is. This is the solution. I'm not kidding. That's the entire technique. You take your prompt and you just say it twice. No complicated chain of thought, no fancy frameworks. You literally just copy and paste your prompt and you get better results. It's almost unbelievable how straightforward this is.
Okay, so the big question is, why on earth does this work? It feels like it shouldn't, right? It's like a weird magic trick. But the answer gets into the very core of how these large language models actually think.
So the secret sauce is in how these LLMs are built. They're what we call causal models, which is just a fancy way of saying they read from left to right, one word at a time, just like we do. A model can't see the end of your question when it's still processing the beginning. And this little limitation is exactly what we're about to exploit.
So here's where it gets really cool. With a normal single prompt, the model is kind of building its understanding as it goes. But when you duplicate the prompt, something amazing happens. By the time the model starts reading that second copy of your prompt, it has already seen the entire query once. It already has the full context.
This analogy from the source paper just absolutely nails it. That first prompt is basically you telling the model, hey, read all of this carefully, get the whole picture in your head. And the second prompt is the signal for, okay, now you can answer me. But it's doing it with the huge advantage of having already processed the entire request. You're giving it a chance to think before it speaks.
So the theory sounds solid, but, does it actually work in the real world? This is where things get really exciting. Google research put this super simple trick to the test across a ton of different benchmarks, and the results are, well, they're staggering.
And they didn't just test it on some random model. They ran this on all the heavy hitters: Google's Gemini, OpenAI's GPT-4o, Anthropic's Claude 3.5, and DeepSeek. So we know this isn't some weird fluke. It's a real, widely applicable phenomenon.
Across 70 different tests, this simple prompt repetition trick won 47 times. I mean, that is a massive win rate for such a tiny change. But hold on, it gets even crazier.
0. That is how many times the regular, single prompt method won. In 70 head-to-head matchups, the repetition trick never, not once, performed worse. It was either significantly better or about the same. Never a loss. That's just wild.
And you can see that consistency right here in the chart from their paper. The solid bars, that's our repetition trick, are just consistently higher than the hatched baseline bars. It doesn't matter if it's a math test or a language test. Across almost every model, it is a clear and undeniable win.
And if you want to see just how big the impact can be, look at this number. On one specific task, the accuracy for one model jumped from just 21.33% with a single prompt all the way up to an incredible 97.33% just by repeating it. That isn't just a small improvement, that's a complete game changer. Okay, so this sounds like a magic bullet, right? Just do this everywhere. Well, almost. It's incredibly powerful, but like any tool, you gotta know when to use it to get the best results. So let's break down the do's and the don'ts.
All right, so you absolutely want to use this for tasks that need structured reasoning. Think math problems, logic puzzles, things with multiple steps. It's also perfect for high-stakes situations where accuracy is everything. On the other hand, you can probably skip it for models that already do some kind of internal thinking on their own because they're basically already doing this. It's also not as great for super creative, open-ended stuff, and you might want to skip it if you're in a situation where every single token costs you money.
For anyone running AI in a real production system, this is where the story gets really, really good. We're not just talking about a performance boost, we're talking about a boost that's essentially free to implement.
I mean, look how easy this is. It's a drop-in change. You just tweak a tiny bit of code that sends the prompt. You don't need new servers, you don't need different API calls, and, this is the big one, it doesn't actually increase the time you wait for an answer. That's because this all happens in what's called the prefill stage, which can happen all at once before the model even starts generating its response.
But there's this other really fascinating benefit, especially if you think about governance. If you're in an industry with a lot of rules, you have to be able to explain why your AI is doing what it's doing. Well, this technique is an auditor's dream. It's simple, it's repeatable, it's explainable. You're not changing the model, you're not doing some weird black magic, you're literally just giving it the input twice to help it think. For compliance, that kind of simplicity is pure gold.
And really, that's the big takeaway here, isn't it? We spend so much time and energy chasing these incredibly complex solutions, building these elaborate systems, and sometimes the most powerful thing we can do is just take a step back and say it twice.
So this whole thing leaves us with a really fascinating question to chew on. In our race to build bigger and more complex AI, what other simple, powerful, almost obvious solutions are we just walking right past every single day? It's a great reminder that sometimes the most elegant answer is also the simplest one.